So how is modern milk made? What's pasteurisation, homogenisation, standardisation, what's permeate, and is our milk watered down? These are all questions I get asked all the time, so I thought today we'll get to the bottom of it. And we'll start with pasteurisation first. That's the simplest. Basically that's heat treatment. It's named after Louis Pasteur, who discovered that heat kills bacteria. So heating milk is pasteurisation, and it works with a time and a temperature combination. So you could heat milk for 60 degrees for 30 minutes and it's pasteurised. You can heat it for 65 degrees for 10 minutes, or you can go for 72 degrees for 15 seconds. And that's what most modern pasteurisers work on. So there's two types of pasteurisation. There's batch pasteurisation, where you heat a batch of milk in one go, like a pot on a stove. And then there's continuous flow pasteurisation, which most modern pasteurisers use nowadays. And with continuous flow, there's constant milk flowing through a heat exchanger, and it gets up to 72 degrees, goes through a holding tube where it's held there for 15 seconds. And then at the end of the holding tube, there's a temperature probe and a valve, and it measures the milk. And if it's 72 degrees, then it goes one way. If it's less than 72 degrees, it flips open and it shoots back around and does it again. So continuous flow is pretty efficient from an energy perspective, but it's complicated. There's lots of fine tolerances. They're expensive to buy and they're difficult to run. So batch pasteurizer is the old way of doing it, and that's how we do it at Happy Cow Milk. So it's important to note that pasteurization doesn't actually change the taste or the composition of milk. If you milked a cow and you took half her milk and pasteurized it and left half raw, you couldn't tell the difference between the two milks. But if you did a lab test, you'd be able to tell. The pasteurized milk would have a lot less bacteria. So the pasteurization kills the good and the bad bacteria. It also deactivates a lot of the enzymes. So many people drink raw milk specifically because they actually want the good bacteria and the enzymes. But standardization certainly does change the composition of milk. We've heard the saying, the cream rises to the top, because if you leave a bottle of milk in the fridge, in the morning the cream has all risen and separated itself and risen to the top. So legally, milk has to have, or whole milk has to have 3.2% fat in it to be considered whole milk. But most cows produce anywhere from 3.5, 4, even 5% fat, depending on their breed and stage of lactation. So what milk factories did in the past is they decided there's no point giving away all that extra fat to the customer and not charging them for it. So they put the milk through a cream separator, and that would separate the milk. You'll have skim milk and cream, and then they would add a bit of the cream back until the skim milk had exactly 3.2% fat in it, and that was called standardized milk. So as time went on, factories decided, well, we can standardize the fat and keep the extra fat and make money from it. Why don't we do that with the protein? Because protein's valuable as well. Legally, milk has to have 3% protein in it to be called whole milk, and cows produce around 3.5% protein. So there's an extra 0.5% of protein there that essentially factories say the customers get in for free. So they developed a system to standardize the protein, but it's much more difficult because protein is much smaller than fat, and basically they developed the ultrafiltration system. So milk is passed through a membrane filter. The white water filters through the membrane, and that's called permeate. And then whatever's left in the filter, that's your fats and your proteins, that's called retentate because it's been retained. And then just like the standardization of fat, you mix the cream with the skim milk. With this, you mix the retentate with the permeate. And the end result is you get a standardized protein level of 3% protein. And that extra 5% protein can go elsewhere or be put into another batch of milk. Now factories using the standardization process are able to basically stretch the milk and make it go 10% further, so they get 10% more milk. So it's profitable for factories to do that. But the factories haven't finished with the milk yet. It still needs to be homogenized. So if you put a bottle of standardized milk that's been ultra filtered, the fat globules will still separate from the milk and you'll still get cream rising to the top. And apparently people don't like this. Homogenization breaks those fat globules down into tiny little fat globules. And the way they do this is by forcing the milk under high pressure through a microscopic hole 0.1 millimeter in diameter. And because the fat globules are so small, they stay suspended in the milk. And the result is you get milk with 3.2% fat without cream rising to the top. So that's why we have homogenization. So is this a good thing or a bad thing? Well, who really knows? There's a lot of debate around it, but I guess all I know is at Happy Cow Milk, when I was doing it, we would batch pasteurize milk and that's all we did. There was no standardization, no homogenization. We simply milked the cows, pasteurized the milk and delivered it. And the cafes would tell us how different our milk was, how more fuller it was and better tasting. And basically we had people who wouldn't drink milk who would drink our milk. Other people would say that they were lactose intolerant or could only drink A2 milk and they could drink our milk. So I don't know, but I just sort of figure that the less we do to our food, the better. And going back to the old-fashioned way is kind of what our principle is here at Happy Cow Milk. So I hope that helps, and if anyone's got any questions about cows, about farming, about milk, whatever, send me an email, glen@happycowmilk.co.nz. Thanks.